All right, next thing we gotta do is deal with when there's numbers underneath the square, underneath the radical. Don't call it a square root a radical. These are hard to do because there's not really a good way to do them with the conversion into exponential form that we did with the letters in the last lesson. So we did this with square roots earlier in the year. It's the same thing, but now there's going to be third, fourth, and possibly fifth roots. All right, it's the same idea. We have to break this apart into the largest, I'm going to call it a largest perfect number because there's perfect squares, perfect cubes, perfect fourth powers. All right, and then we have to split the radical into two radicals that are factors. One of them needs to be a perfect number. All right, then we take the root of the perfect number and leave the other thing under the radical. There's really no better way to do this. I've tried to figure out like a better, easier, shorter way to deal with it, but I haven't been able to figure out anything that works any better than just doing it this way. So it's gonna be a bit of a headache. So we did earlier in the year square root of 50 or radical 50, and then we figured out that the largest perfect square in there was 25, and 25 times 2 is 50. We were able to take the square root of 25 and get 5, and then the radical 2 was left there. We did that earlier this year. That isn't really bad to do because we would take the 50, put it in the calculator, get the factors, and we have a reasonable idea of what perfect square numbers are. When we go to third roots, fourth roots, and fifth roots, we probably don't have third perfect cubes and perfect fourth power numbers actually memorized. We have to be able to pull them from someplace. So we're going to show you a calculator thing you can do to get them. But basically, this is just the better you are at number facts, the easier this is. The worse you are, the longer it takes. It's still possible because you have a calculator. All right, so if I had third root of 40 and I was supposed to simplify it, 8 is a perfect cube because it's 2 times 2 times 2. All right, that's 8. So that's why 8 is a perfect cube. Again, if you have that memorized, it's unlikely. We're going to show you how to get it from the calculator. All right, but the cube root of 8 is 2. So I'm able to take the 2, the cube root of 8, and turn it into a 2. What happened when I did that is I was left over with a cube root of 5. So I had a cube root of 8 times a cube root of 5 because 8 times 5 is 40. All right, so I'm factoring with just numbers again. Since I can't take a cube root of 5, it stays. All right, now I fully understand that this is going to take a ton of practice. And again, the more trouble you have finding factors of things, the longer this is going to take. But we have to be able to at least figure out our way to an answer with these, or else we're just kind of stuck with nothing.